Our first speaker is Dr. Alison Clark Wilson, the Principal Research Associate at the Institute of Education at University College London. Alison's well known in the maths education community for her research into and passion for digital technologies. And she currently leads the Educate project at the UCL Knowledge Lab, which supports teachers in designing the right digital learning platforms. So thank you very much and welcome, Alison.
Thanks, everybody. Hello to Linz, and good to see you all again. Thank you very much to Lynn and the team for inviting me. I was also very honoured to be asked to speak at the launch, which is 2.5 years ago, and share some of my thoughts around aspects of digital technology and mathematics education. What I'd like to do in this session is actually to step back a little bit to sort of a system level view. So looking at what we've learned from 25, 30 years of research on how mathematics has or hasn't integrated digital technology within systems, reflect on some of the experiences from this country. We've had some major big projects, which you might, they've long died a death, that says quite a lot, but also what we've learned around what needs to be in place for a curriculum that does embed aspects of digital technology to stand a chance of being scaled. So I'm going to talk a little bit about necessary but not sufficient conditions for moderate success. And this is, if you look at the research domain around technology use in mathematics, we had years and years and years of exploratory design research-based projects where, there were good cases for particular designs of technology impacting positively on both teaching and learning. We've had very few large-scale experimental studies for lots of really good reasons, mostly to do with the fact that the process of learning to use and implementing technologies with mathematics is really challenging and it takes time. And so to fit with particular design research, particular research strategies, it really isn't a good fit to be able to say, definitively, this technology works well in all these circumstances. So the methodologies through which we decide if technology works or not is part of the challenge here. So a little bit of looking back, looking at where we are around the world, because there's some interesting differences that are emerging around the world with respect to, at country and district level, how technology is being embedded in the curricula, and just a little peep, a mention of a project that's around the corner. So these 6 themes recur in all of the evaluations or research studies that do try to look at whether or not technology in mathematics is having some impact. There has to be a vision, and it's interesting that, there's a vision in the minds of the designers of the technology, there's a vision in the minds of the curriculum designers, there's a vision in the mind of the policymakers or those who sort of guard the content of the curriculum. So those visions play out in different places, and people have very different visions for what technology might be used and when. So we have a lot of drill and practice type technology out there. For the people who design that, that's the right sort of technology for the purpose for which they're designing it. I'd like to focus minds onto what I would call mathematical technologies for which, by engaging with them, you are doing or certainly thinking about mathematical ideas. So they are the genre of technologies like dynamic geometry software, computer algebra software, dynamic statistical softwares, where you've got to do maths to be able to engage with them. So we'll put to one side generic technologies like whiteboards or tablets, which, in their own don't bring any mathematics into the picture. For years and years, it was about access, and there was a lot of thought, when we finally solve the access problem, then we can really take off. So access to technology is key, both for teachers and learners. But in thinking about that, it's more than just having the kit. for teachers who are engaging with mathematical technologies, it's a really steep learning curve to come to know how the mathematics is represented in that software and therefore how you exploit it for your pedagogic purposes. It doesn't come on the instructions how to do this. So the access is more than just having it. It's for the teachers and learners and actually curriculum designers. How do you make the most of the affordances that technology offers? And how can you be critical about whether it's the right technology in the first place? We can't get away from beliefs. It's interesting, values and beliefs came up earlier in Jeff's talk. People have very strong attitudes about, and this is beliefs about the mathematics, and therefore the sort of representations that you might be presented within a digital technology. For some teachers, the last thing you want is children dragging something and changing it. For another teacher, that's the point, to be able to drag things and change it. And that's where the beliefs come in. And those are the beliefs in the curriculum designers, the assessment designers, the policy makers that might be the gatekeepers. So the beliefs is always in there. And it's a challenge for, in the same way it was a challenge earlier, to think about, well, what does constitute your curriculum? Then you come to the actual curriculum itself, and I've sort of approached that sort of in a traditional thinking of, well, we have got some content, we have got some sort of list or map of what we feel is important to teach, and it may or may not suggest particular pedagogies, and somewhere down the line, we're thinking about how we can assess that mathematics in a way that is true to the content and the pedagogy. So this is often where, with digital technologies, we've had some of these pieces in place, but the assessment hasn't changed. And that's a challenge for everybody in the landscape, because why should teachers take up technologies when, at the end of the day, the assessments that the students are sitting really don't build on that experience or that way of learning or that way of representing? So if these are aligned, one of the key elements at every stage here is professional support for teachers. You can't come in and change the assessment and suddenly expect a particular technology to be used without thinking about the professional support for teachers. You can't revamp the curriculum without thinking about that. New technology comes into the school. Teachers need support to be able to time and support, and that's time over time, as well as substantial time to think about these things. And you have to start somewhere. What's really interesting is every teacher has a first lesson with a technology at some point in their professional career. How can we best support that to take account of the fact that we know first lessons rarely go to plan with technology? That's part of learning to think about whether that technology is going to be supportive in what you're doing. So a couple of projects, a little bundle of projects from the past. Going back, nearly 20 years, we did have a really strong vision for technology in this country, in the curriculum. We had some explicit statements. People were generally optimistic and thought these would be useful. Things like students should use some sort of technology to explore functions and their relations with tables of values and piece together the representations of algebra. And we had big programs like the New Opportunities Fund, ICT training. We had some DFE-funded projects, the Practical Support Pack. All of these were trying to create some really forward-looking materials and content to be used in schools. Sadly, my ambers aren't so good up in that colour, but the access to technology wasn't there. So we primed a lot of teachers with training, but when they went back into schools, this is, early days of the internet, still with that dial-up thing, and it was too soon. The conditions weren't right. We did reach some people. Some people did get the bug. The beliefs were there. People could see how some aspects of maths might be approached differently. We had some good content being developed, but on the whole, we didn't really understand what these new pedagogies might be, and there certainly hadn't been any shift in the assessment. So a pause. This sort of image had I put a regular polygon up there, could easily have come from a software package like Logo. Interestingly, I don't know how many of you have experienced trying to draw an irregular polygon in Logo. It's always interesting how many, particularly working with teachers, start to go down that line and then realize there's an awful lot more mathematics you want to know. But this example in a Logo context was interesting because it did used to be assessed. Key Stage 3 assessments would have this odd question every few years, which basically set the students a Logo-style external angles type problem. And it sort of sat on its own in there, and it didn't really relate. And then when dynamic geometry came along, which was, it followed on from that, images like this next one suddenly became possible. And, oops, didn't my animation stop playing? Have I got animation? I'm going to ask my guy at the back if we can see that move, because it would be really nice to. It is a dynamic image. Going to get that? No, if not, I'll skip through. And you're going to have to use your imagination, which is such a shame, because it's such a... Oh, there you go. So did you ever make that connection that no matter which polygon you have, if you have the external angles marked, you also had another image that you could have used to think about a really key bit of mathematics in Key Stage 3 geometry curriculum in this country? And that idea that, by stretching those, your imagination in a way, I suppose that's what switches me on to technology. I know I have a passion for particular technologies used for particular areas of mathematics, but it is that how you can gain insights or make connections between areas of mathematics which might otherwise have been distinct. And if that's going to bring advantage to your understanding, then it seems to be something that is worth thinking about. So moving on quite a number of years to a more recent project, which was Cornerstone, there was a few more pieces in place in this one, in that, again, there was a strong vision in terms of the design of the materials. Access in schools is better, a lot more schools with student access to technology. There was content, there was pedagogy, but we still have that red blob at the end there, which is about how does the experience of learning mathematics with technology get acknowledged in any aspect of assessment? It's a big open question for us. Does it? And if so, what might that look like? So, critical factors. Things do have to align. I mean, if you take things at that system level, once you take it to the school, these ideas still need to align in terms of the professional support for teachers, looking at how the localized scheme of work does or doesn't embed some of these aspects. And it's tricky because the technology is a bit disruptive. So you've got this tension that you want alignment and you also want to try and support and change new pedagogies, new ways of thinking about things. And professional learning for teachers takes time, and the nature and the design of the assessments is a really key factor here. So to finish off, what is the scenario that gives us green lights all the way through? Well, I honestly don't think there's anywhere out there that's doing this yet, in a country or district-wise way, but there are some signposts. This is an extract from the National Curriculum for Mathematics for Norway, and I'll leave you with this one. So it's very articulated in its view of where digital technologies sit within mathematics. And it's not a surprise that in the recent PISA analysis that looked at technology use around the world, students in Norway were reporting very high levels of technology use in mathematics. And what we don't know is any links between what happens in Norway and outcomes. And part of that is because the whole system's dynamic. So the kids in the PISA test probably, at what point do you decide that that is embedded in the system, at which you may or may not see any impact on overall PISA scores? Do the PISA assessments use technology? I'll leave you there. Thank you.